Hello everyone. Hope you are doing very well. So as you all know that today we are going to cover the theory part 12 of the chapter Haloalkanes and Haloarenes. So let's begin our today's topic. NCRT chapter 6 Haloalkanes and Haloarenes theory part 12, and today we are going to cover the NCRT section 6.8 to 6.8.3. This is disclaimer. Objective of today's lecture. So after attending this lecture, you will be able to highlight the environmental effects of polyhalogen compounds. So today we are going to focus on the effects of polyhalogen compounds. The topics that we are going to cover according to the NCRT. First of all, the section 6.8, polyhalogen compounds. Then we will cover the section 6.8.1, dichloromethane. Then the section 6.8.2, triichloromethane. And then the section 6.8.3, triiodomethane. And lastly, we will solve an text question 6.5. So let's start with our first topic 6.8, that is polyhalogen compounds. So halogen, that means halogen group atoms. Poly means more than two or more than one. Okay, so poly means many. Wherever poly word comes, that's is suggesting that something is in very large amount. Okay, so polyhalogen compounds. What are those? So carbon compounds with more than one halogen atom. Okay, because we are saying polyhalogen, that means more halogen is going to be present in those compounds. So the carbon compounds having more than one halogen atom are known as polyhalogen compounds. So for example, if you see, we have this two structures here given. First, for 1,2-dichloro, 1,1,2 triofluoroethane. You can see we have two carbon compound, and so this is ethane. Okay, no, every bond is single bond, so that's why we are calling it ethane. And we have at the very first position and the second position we have two chlorines, so that's why we are writing 1,2-dichloro as per alphabetical order. And at the first position we have two fluorines, so we are writing 1,1, and at the second position we have one fluorine, so 1,1,2 triofluoro. Three fluorines are there, two at first position that are indicated by numbering this one to twice, and then two is denoting the position of second fluorine which is present at the second carbon. Okay, and total three fluorines are there, so triofluoroethane. Okay, so the name is 1,2-dichloro, 1,1,2 triofluoroethane. Now if you look at another structure given, it is having only single carbon, so it is methane. Okay, now at this single carbon you can call it first position of the carbon. At this carbon we have bromine, at the same carbon we have chlorine, at the same carbon we have fluorine, and along with the iodine. Okay, so at the same this carbon tetravalency is occupied or is fulfilled by these four halogen atoms: fluorine, chlorine, bromine, and iodine. Okay, so the name is 1-bromo, 1-chloro, 1-fluoro, 1-iodomethane. The name is as per the IUPAC nomenclature, and the name of the halogens are arranged as per the alphabetical order. Okay, anyway, if you see these two structures, you can see that we have more than one halogen atom present in the same structure. So in the first structure we have two chlorines, we have three fluorines, right? So more than one halogen atom is present, so this comes under the polyhalogen compounds. Similarly, in the second structure you can see we have fluorine, iodine, chlorine, and bromine. That means we have four different halogens. Okay, not single halogen is present in this structure, four different halogens are present, so this structure will also comes under the polyhalogen compound. These halogen meanwhile are different, but still we have halogen category compounds or halogen group atoms which are more than one. We have four different halogen atoms present in single structure, so this compound will also be called as polyhalogen compound. They are useful in industry and agriculture. So in the two major fields, that is in the industry and in the agriculture, we use these polyhalogen compounds. Let's first explore our first polyhalogen compound, 6.8.1 section, dichloromethane. Okay, you can also call it as methylene chloride. Okay, so its structure, uses, and the health effects of dichloromethane. So if we talk about the structure of dichloromethane having formula CH2Cl2, the structure is CH2, that means only single carbon compound is and the two valencies occupied by hydrogen and the other two are occupied by the chlorine atom. Okay, so this is a polyhalogen compound because two atoms of halogen are present of chlorines. Okay, so this is the structure of methylene chloride or dichloromethane. Now, if you talk about its uses, we use it as a solvent in the process of paint remover. Okay, so in the process of paint remover, we use the dichloromethane as a solvent. We also use it as propellant in the aerosols. What is propellants? Propellant is a you can say poisonous fuel that cause something to move forward. Okay, and aerosols are the particles, small particles that are suspended in our atmosphere. Okay, so we use the dichloromethane as a propellant, as a fuel in the aerosols. We also use dichloromethane in the process solvent in the drug manufacturing. In drug manufacture, we use the dichloromethane, and the fourth use is metal cleaning and finishing solvent. Okay, so in the metal cleaning and degreasing, we use dichloromethane significantly. So these are the uses of dichloromethane, or you can call it methylene chloride. Both are the name of this structure given. This is a polyhalogen compound. Now, if we talk about the health effects of dichloromethane, harms the human central nervous system. So dichloromethane can harm the human central nervous system, and if you take it in a lower amount, okay, through air. So if it is present in the lower exposure in the air, it can slightly impair the hearing and the vision capability. Okay, so you maybe face some problem in the hearing of the voices, and also your vision can also be disturbed by the presence of dichloromethane in the lower exposure in the air. Meanwhile, on the other hand, if this is present in higher exposure in the air, it can cause dizziness, nausea, tingling and numbness in the fingers and toes. Direct skin contact. Now, if the dichloromethane comes direct in the skin contact, then it can cause intense burning and mild redness over your skin. So this is very harmful, and if it comes through our eye contact directly, then it can even burn the cornea. So vision will be permanently impaired, or you can say destroyed. Right? So the dichloromethane, a polyhalogen compound, it has a lots of health effects, health bad effects. Okay, it can cause it can make you blind. It can burn your cornea if it comes directly in contact of your eyes. Now, let's see the next polyhalogen compound, that is trichloromethane, or you can call it as chloroform. Okay, it is our next section, 6.8.2. So, if you talk about the structure of your trichloromethane having formula CHCl3, that means one carbon is going to be there and three chlorine atoms, three chlorine halogen atoms is going to be there in the structure of trichloromethane, as the name says. So you can see the structure. We have single carbon, and on this single carbon we have one hydrogen, and the other three valencies are occupied by the three chlorine halogen atom. Okay, so CHCl3. Okay, so the structure is CHCl3 for trichloromethane. Now let's see its uses. You can also call it as chloroform. We generally call it as chloroform. So chloroform name of this compound is more famous comparatively. Now let's talk about its uses. The chloroform is used as solvent for fats, alkaloids, iodine, and the other substances. Okay, so this trichloromethane can be used as a solvent for the fats, alkaloids, iodine, and other substances. Fats, they are, the unsaturated compound long chain structure. Alkaloids are natural organic compounds which contain at least one nitrogen atom. Iodine is iodine and the other substances. So for all these substances, trichloromethane or chloroform is act as a solvent. The major use of chloroform includes the production of freon, which is a refrigerant R22. It has even a name, R22. Okay, so for the production of freon refrigerant R22, specifically this type R22, we use chloroform, and it is the major use of the chloroform. Okay, freon is basically a refrigerant. That means it is used to transfer the heat in the cooling systems like AC, air conditioner. Okay, it comes under the chlorofluorocarbons and hydrochlorofluorocarbons. Okay, so chloroform major uses in the production of freon refrigerant called R22. The third use is it formerly used as a general anesthetic in the surgery. So it is replaced by less toxic alternatives like ether later. So the chloroform also used as a general anesthetic in the surgery process in the medical field. Okay, and later the chloroform is replaced by less toxic alternative, which is ether. Okay, so nowadays we use ether as a general anesthetic in the surgery at the place of chloroform, because chloroform has a toxic nature. You can see its major use in the production of freon, which is very, very harmful for our environment and our ozone layer, right? So for the lesser toxic alternative, we use ether as a replacement, as an alternative for the use in the general anesthetic in the surgery. Okay, so these are the uses of chloroform. Now, if we talk about its health effects, how can it affect our health? Inhaling vapors depresses the central nervous system. If you take the chloroform vapors, if you inhale the chloroform vapors, it can depresses or destroy your central nervous system. Short-term exposure up to 900 parts per million. It can cause you dizziness, fatigue, and headache. So what we are saying, that if you take this in a short term, okay, if you have this chloroform in a short-term exposure in the 900 parts per million. What does this mean? 900 parts per million means the solution is very diluted in this concentration. Okay, so that means the concentration of chloroform is very short, very less. So in the short-term exposure, it can cause you dizziness, fatigue, and headache. They are the you can say effects on the health of a human being after the short-term exposure of chloroform. If you take chronic exposure, it can damage to your liver, okay, metabolized to phosgene and kidneys. So chloroform, if you take in the chronic exposure, that means more than enough. Okay, if you take the large amount of chloroform, then it can cause the damage to your liver, and it will be metabolized to phosgene, which is very poisonous gas, very poisonous, very dangerous, and it can also damage to your kidneys. Skin immersion, it can cause sores, so it can also affect your skin. The effect on your health is by the exposure of chloroform is one of by contact in via your skin. Okay, so if chloroform comes in contact of your skin, it can cause sores, it can cause red rashes, or a pimple type of thing on your skin. Safety and storage. Now it has lots of health effects, right? So what is the safety measures or the storage conditions that you have to follow while it's storing, or while the storage of the chloroform? What are the safety precautions that you have to take? Stored in closed, dark colored bottles, completely filled to exclude the air. What we do, we take this chloroform. So how we store it? We store it in a closed, first of all, the container should be closed properly, so that it should not comes in the contact with air. It cannot it should not comes out of that container. So the container should be stored, the container should be closed properly. Second thing, the bottle that you are using to store the chloroform should be in dark color, so that even light cannot cross, or even light cannot comes in contact with the chloroform for its adverse effect. Okay, now third thing is completely filled to exclude the air. Now container, when you are storing the chloroform into the container, when you are transferring the chloroform into the container, you have to fill the container up to the brim. Okay, you have to completely fill the container so that none of the air can enter inside of your bottle, or it can pack inside your bottle, so that air cannot react with the chloroform and form a poisonous you can say gas as a product, which will also be like dangerous. Okay, so these are the safety measures you should take while the storage of the chloroform. It should be stored in the closed container. The container or the bottle should be in dark colored, so that it cannot comes in contact with the light for its effect or for its reaction. It should be the bottle or the container should be completely filled to exclude any kind of air inside the container. Okay, let's do the question. Question is, why is a bottle of trichloromethane or chloroform filled up to the brim? So we just have discussed, right? The question asking is, you have to explain the reason that why the bottle of the chloroform, the bottle in which you have stored the chloroform, should be filled up to the brim, up to, like, it should be filled completely. Why is it so? So you have given some time. Try to solve this question, and then we will see the correct answer. Okay, let's see. So for this question, we can answer this question by putting the points, okay, one by one, that why you should completely fill the bottle of chloroform while it's storage. Air might enter into the bottle if the bottle is not fully filled. So if you're not fully filled the bottle in which you are storing the chloroform, then air might capture or air might enter inside the bottle. What will happen through that? So trichloromethane or chloroform, due to the air contact, gets slowly oxidized due to the presence of air. Okay, so if you are not completely filling your bottle, air might enter into the bottle, and in the presence of that air, the chloroform can get slowly oxidized. And during the oxidation process, the chloroform, the trichloromethane, releases a poisonous gas which is called as phosgene. Okay, so the product that you are getting after the reaction with the air, after the interaction of chloroform with the air, is called as phosgene, and this is also a poisonous gas, very, very harmful. So when this chloroform, CHCl3, are oxidizing in the presence of air, that is oxygen, and also light, then you will get a compound or a gas which is called as phosgene, which is a poisonous gas, very harmful, plus twice of hydrochloric acid as your byproduct. Okay, so due to the formation of this poisonous gas, after chloroform comes in the contact with the air, with the oxygen, in the presence of light, this is the main reason that why your bottle should be filled completely up to the brim while the storage of the chloroform inside the bottle. Let's see the next question. Why ethyl alcohol is added into the bottle of trichloromethane or chloroform? So we are discussing some safety rules while the storage of chloroform we should take. The second question asking is, ethyl alcohol is added into the bottle of chloroform while it's storage, then now why you do that? Okay, why you have to do that? You have to tell the reason. So you have given some time, try to solve this question, and then we will see the correct answer. Okay, let's see. For this question, first of all, we have seen that oxidation of chloroform results in the formation of phosgene gas, which is actually a highly poisonous or highly toxic gas. Okay, so the product you are getting after the oxidation of chloroform is also poisonous, is also toxic. So we should avoid the oxidation of chloroform to happen, right? And ethyl alcohol we are adding to the bottle of trichloromethane, which is acting as a scavenger for the phosgene gas. Okay, it will prevent the happening or the formation of the phosgene gas. Alcohol will react with the phosgene and converting it to diethyl carbonate, which is a non-toxic compound. Okay, as soon as if there is any contact of chloroform with the air, if possible. Okay, so if there is any contact of chloroform with the air, what will happen? The formation of phosgene gas, a highly toxic gas, will carry on. Okay, now if the phosgene gas formation takes place, we are adding ethyl alcohol to the chloroform so that the phosgene gas we just formed, or you can say phosgene gas just formed by the oxidation of chloroform, will react with the ethyl alcohol. Okay, so you can conversely say ethyl alcohol, which we have added to the chloroform, reacts with the phosgene gas just formed and convert it into diethyl carbonate. Formula C2H5O CO OC2H5, or you can say C2H5O whole twice CO, right? And this actually diethyl carbonate is a non-toxic compound. Okay, so that's why we are adding ethyl alcohol into the bottle of chloroform, so that if in any case there is a formation of phosgene gas takes place, the ethyl alcohol react with the phosgene gas, convert it directly into the diethyl carbonate and change its nature from highly toxic gas to a non-toxic compound. So if you see this, we have COCl2, okay, and this is phosgene. As soon as it forms, it reacts with the ethyl alcohol C2H5OH and directly convert to diethyl carbonate, that is C2H5O whole twice CO plus 2HCl will be your side product. This is the same product that you are getting while the formation of phosgene gas also, right? So a highly toxic gas will be converted to a non-toxic compound by the reaction of this gas with ethyl alcohol, and that's why we add ethyl alcohol into the bottle of the chloroform where we are storing it. Okay, now let's focus on our third polyhalogen compound under the section 6.8.3, which is triiodomethane, or you can also call this compound as iodoform. Its structure, uses, and properties of triiodomethane. Let's see, CHI3. So the structure is this, where we have single carbon compound. This carbon is connected with 1 hydrogen and 3 iodine atoms. Okay, so this is CHI3, triiodomethane, and the past use of this triiodomethane is it is formerly used as an antiseptic in the previous times. Okay, but and also it is used as an antiseptic. So its antiseptic properties is due to the liberation of free iodine. So it can liberate free iodine. That's why it is used as an antiseptic in the past time. Current status, if you see, in the today's time, it is replaced by other iodine containing formulations due to the objectionable smell. Okay, now we have used the iodine or triiodomethane as an antiseptic in the previous use because of its ability to release or to liberate free iodine molecules. But in the current time, in the current status, it is replaced. So its use as an antiseptic is replaced by other iodine containing formulations. Why? Because this triiodomethane has an objectionable smell, which is kind of you can say disturbing. Okay, so example is povidone iodine and iodine tincture, a solution of iodine in the alcohol we use as an antiseptic in today's time. Okay, at the place of triiodomethane due to its objectionable smell, its uncomfortable smell. Okay, so these are the examples of the replacement of triiodomethane as an antiseptic that we use in current time. Povidone iodine and iodine tincture. You have listened, or you have you probably have listened about this iodine tincture, right? Okay, let's solve an Intext question. Intext question 6.5. The question is, draw the structures of major monohalo products in each of the following reactions. So we have given different part, at most 6 part of this question, in which in each part we have given the reactions along with their reactants and reagents, right? You have to draw the structures of major monohalo compounds in each of the following part. Okay, so the product is monohalo product. That means only single halogen is going to be there in the product, and you have to draw the structure of the products in each of 6 cases. So you have given some time, try to analyze this question, and then we will see the correct answer. Okay, let's see. So for this question, let's see one by one. Okay, the first reaction is between this alcohol and SOCl2, right? So the reaction of alcohol with thionyl chloride yields alkyl chloride and SO2 plus HCl as a byproduct. So what we are saying, that this cyclohexanol plus SOCl2 will give us chlorocyclohexane plus SO2 plus HCl. Okay, so this cyclohexanol, what will happen? We have, if you want to know the mechanism, this reaction happens by the you can say attack of SOCl2 on this oxygen. Okay, so what will happen? This oxygen has lone pairs, so this is going to be bond with this sulfur. So SOCl2 structure is S double bond O, and S is also bonding with two chlorines. Okay. So what will happen? The oxygen lone pairs will attack on this sulfur, and the bond will form between oxygen and sulfur. Okay. After which the oxygen attain positive charge, and this hydrogen attaching with this oxygen will be removed from here after the attack of chlorine, one of the chlorine from the SOCl2, which we just have removed. Okay, so when the oxygen and sulfur bond is forming, one chlorine is removed from SOCl2, and then that chlorine will also attack on this hydrogen. So this hydrogen will also be removed, and you will got a cyclohexane, where at this carbon we have OS double bond OCl attached. Now this OSOCl is a good leaving group, so it will left from the cyclohexane ring, and you will got a carbocation here at this position. And then what will happen? The SO2Cl, okay, S double bond OCl, and one bond is bonding with O minus. Okay, so what will happen? That O minus charge will go over the sulfur to form the double bond with the sulfur, and the chlorine attaching with the sulfur will be removed and attack on the carbocation just formed. Okay, and after that we will got our final product as chlorocyclohexane, and SO2 will be removed plus HCl that has formed in the very first and second step. Okay, so HCl and SO2 will be your byproduct, and your major product will be the alkyl chloride, that is chlorocyclohexane, which is a monohalo product. Right? Now for the second reaction will be the monobromination of substituted arene in the presence of UV light. So what will happen? You have this 4-ethyl nitrobenzene. That means at the fourth position we have ethyl group CH2CH3. At first position we have nitro group, which is an electron withdrawing group, and we have benzene ring. Okay. Now when you are reacting, you are doing halogenation of this, you can say 4-ethyl nitrobenzene in the presence of UV light. What will happen? This bromine is going to be released as a free radical. Okay, so this reaction is happening via free radical mechanism. Bromine will release free radicals. Also, we also got this ethyl free radical. Okay, and then bromine will going to attack on this ethyl free radical and form this product, that is 4,1-bromoethyl nitrobenzene. So at this very second carbon in the ethyl group, the bromine will going to attach, and NO2 will be remain at the same position, plus HCl will be your side product. So in the second reaction of bromination of substituted arene in presence of UV light, you will get a 4,1-bromoethyl nitrobenzene as your major monohalo product. Okay. Now let's see your third reaction. The third reaction is reaction of alcohol with the hydrogen chloride, right? Reaction of alcohol with hydrogen chloride, or you can say halogen acid. Now the reaction of alcohol and hydrogen chloride yields alkyl chloride. What we are saying, if you have this 4-hydroxymethyl phenol as your reactant and it is reacting with halogen acid or HCl, this OH will be replaced by the chlorine, and you will get 4-chloromethyl phenol as your major product, plus water molecule will be released from the reaction mixture. Okay, so hydroxyl group will be removed from here, and the chlorine will attack here, and chlorine bind with this CH2, and this OH will be bind with this remaining hydrogen and form water molecule as a byproduct in this reaction. So the major product, the major monohalo product you are getting is 4-chloromethyl phenol. Now if you see the fourth reaction, which is addition of halogen acid, again which is hydrogen iodide, to an alkene, it will proceed via Markovnikov addition rule. Okay, so in the alkene we are adding an halogen acid, which is here is hydrogen iodide. So this is your 1-methyl cyclohexene, and it is reacting with the hydrogen iodide halogen acid. So what will happen? This reaction will follow Markovnikov addition rule. Marconic evaluation say that the negative part or the iodine will attach to that carbon of double bonded carbon that is more substituted or that is having lesser number of hydrogen. So these two carbons are double bonded carbon. This carbon is 3 bonds is here and 1 bond is with the hydrogen. Now this carbon 3 bond are in the chain in the ring and 1 carbon and 1 bond is with this methyl group, right? So the lesser hydrogen containing double bonded carbon is this one where the methyl group is present, right? So the iodine will attack on this double bonded carbon and you will get your major product as 1 iodo 1 methyl cyclohexane by following the Marconic addition rule in this reaction. Okay. Now, if we see the fifth part, okay, which is the reaction of alkyl halide with sodium iodide. And this is actually a Finkelstein reaction, which is a halogen exchange method. How? So when you are reacting bromoethane, that is CH3CH2 bromine plus sodium iodide. So when you are reacting the alkyl halide with the sodium iodide, the halogen exchange method or the Finkelstein reaction will happen and the halogen will exchange among the reagents. So this bromine is exchanged by the iodine or replaced by the iodine and you will get sodium bromide as your byproduct. And the major product is iodoethane. So in the fifth reaction, you are getting your major monohalo product as iodoethane. Now, if we see the sixth reaction, which is the reaction of alkene with the halogen. So this reaction will proceed via radical mechanism because this reaction is happening in presence of heat and UV light, right? So what will happen? The radical stable on allylic position. Now the radical when combining with the alkene, it is going to be stable on the allylic position after the formation of the bond. What I'm saying? So if you have this cyclohexene ring, this is an alkene, it is reacting with the bromine molecule in the presence of UV light. Now this reaction is happening via radical mechanism. You will get bromine 2 radicals and this bromine radical will be stable on the allylic position of the alkene. That means it will attack on the allylic position of alkene, which is actually the position where there is sp3 hybridized carbon, but it is bonding with a sp2 hybridized carbon. So you can see this third position and you can also count from here 1, 2, 3, this position. They both can count at third if you start from here or here, right? So if you start from this carbon 1, 2, 3, okay, so the lower numbering will be at the double bonded carbon. So at the third position, which is a allylic position, because this carbon will be the carbon that is attaching with bromine and bromine is a halogen. So halogen is attaching with the carbon which is sp3, but this carbon is attaching with sp2 hybridized carbon which is involving in the double bond. Okay, so the radical, the bromine radical is going to stabilize on the allylic position of alkene and you will get your major product as 3-bromocyclohexene plus HBr will be your side product. Okay, so these are the reactions along with their major monohalo products that you just have seen for each part of this question. Okay, let's talk about the summary. So what we have covered today. Firstly, we have focused on the polyhalogen compounds. They are the carbon compounds with more than one halogen atom, right? So the carbon compounds containing more than one halogen atom, they are known as polyhalogen compounds, right? For example, we have seen different kind of polyhalogen compounds. The first one is dichloromethane. Dichloromethane is, that means one single carbon and 2 chlorine are present. Dichloro, that means 2 chlorine. So one single carbon, because methane we are talking about. Single carbon attaching with 2 chlorines and 2 hydrogens. So this is the structure of dichloromethane. We have seen its various uses and the health effects of using or exposing after the exposure of this dichloromethane molecule. Now, the another example we have talked about of polyhalogen compound is triichloromethane, where trichloro means 3 chlorine are going to be there. So we have one carbon which is attached with 3 number of chlorine atoms and 1 with the hydrogen atom. Okay, this is also a polyhalogen compound. Okay, more than 1 halogen atoms are present, which is chlorine in this structure. So this is a trichloromethane. We have also seen for the trichloromethane its uses and its health effects. We have also seen its storage and the precautions while its storage, right? Third example we have seen for polyhalogen compounds as triiodomethane. Triiodo means 3 iodine are going to be there and 1 will be hydrogen after completing the tetravalency of the carbon. Okay, so 1 carbon attaching with 3 iodines and 1 hydrogen. This is the structure of triiodomethane, and we have also talked about its uses and health effects. Okay. Okay, thank you so much. That's all for today's chemistry session. Thank you.